Morning children, Sai Ram, welcome to this session. Today we are going to continue with the lesson towards green energy. Now we had learnt in the previous video about hydroelectric power station as well as about wind energy, how electricity can be produced by wind. Now let us continue with the lesson. Today in this session we are going to learn how electricity can be produced by solar energy. Okay. Many of you all, we all know about we can get electricity from solar energy, because in the projects also you all do about solar energy. Now let us learn, there are two methods of electricity generation in solar energy. Let us learn both of them. Okay. So in the above previous methods, we had studied that electric generator is driven, okay, by using any other of the energy sources, either by water, steam, okay, and making the use of electromagnetic induction. We learnt in this above processes the same thing, and the turbine is rotated with any of the energy sources, okay. But in electricity can be generated by solar radiations without using generator and using the principle of electromagnetic induction. Though there is no need of this electromagnetic induction, directly the solar energy can be converted into electricity. This happens in solar voltaic cell with the help of the solar. All of you would have seen the solars. We have seen about the silicon cell, solar energy with the help of the solar photovoltaic cell. The solar photovoltaic cell converts the solar energy directly into electric energy. Okay. In the second method, what we're going to learn is the same way as the energy in the solar radiation is converted into first thermal energy, and then the turbine is rotated as we got it in coal, using coal thermal power stations. What the same thing happens, isn't it? When the coal burns, it is converted into thermal energy. So even in the nuclear reactor, the thermal energy is produced. That helps to rotate the turbine. The same way here, the solar radiations is converted into thermal energy first, and then the turbine generator system is driven using the thermal energy to generate electricity. So first one was directly solar energy to electricity using the photovoltaic cell. That we will learn in detail. Okay, now let us see the first method using the solar photovoltaic cell. This solar photovoltaic cell converts the solar radiation energy directly into electrical energy. So that is the work of this solar cells. With the help of the solar voltaic cells, the solar energy is directly converted into electricity. Okay, this is called as solar photovoltaic effect. The electrical energy generated through this energy transformation process is DC, direct current. You get only direct current, okay. These solar cells are made up of typical type of material called semiconductor, which is made up of silicon. We have learned this in lower standards. Made up of semiconductors called as silicon. It is usually of silicon, and the energy which is got is direct current from the solar cells. Now the silicon solar cell of dimension 1 centimeter square. Okay, look at the dimension of 1 centimeter square generates about 30 milliampere ampere current and a potential difference of 0.5. So 1 centimeter square of cell of the solar cell or silicon cell you will get 30 milliampere of energy current as well as a potential difference of 0.5. So when you take 100 centimeter square of cells, solar cells, you will get about 3 ampere. That means 30 into 100. Okay, that is 3000 milliampere, or it is 3 ampere. 3000 milliampere is 3 ampere. So 3 ampere current as well as under current and potential difference of 0. So potential difference will not change. Only when you take 100 solar cells, silicons of dimension, solar cell of 100 centimeter square dimension, you will get 3 ampere of current and potential difference of 0.5 volts. Okay. Now, now we'll see how the figure is. When the energy See the energy from sunlight with the help of the photovoltaic cell, it is converted directly into DC electric power, not the AC one. It is DC power. Okay. If two solar cells are connected in series, now we'll see, you have learnt in the science say about series and parallel, isn't it? Now when it is connected in series, the potential difference obtained in this combination is addition of the potential difference of individual solar cells. So when it is connected in series, the potential difference is added. However, the current generated from combination is equal to the current from the individual cell. Current is only according to the individual cell, but the potential difference when you are connected in series will be added. That means if the solar cells is connected in series, current from individual cells are not added. That means, so see here, you can see if it is connected in series like this, only the potential difference, see this V, okay, that will be added, V1 plus V2, and the current will be the same. It will be I is equal to I1, that is equal to I2. So the current is not added, only the potential difference is added when the solar cells are connected in series. What is added? Potential difference is equal to V1 plus V2, that is the potential difference. But the current is the same. I is equal to I1, that is equal to I2. The current is not added, only the potential difference of the two cells are added. Same way, if we are connecting the cells in parallel, the current generated from this combination is the summation of the current from the individual cells. So if it is connected in parallel, in a series we saw only the potential difference is added, but if it is connected in parallel, the current of the individual solar cell, it has to be added. That means I is equal to I1 plus I2, and the potential difference will remain the same. Okay. So if the two solar cells are connected in parallel, the potential differences of the two cells are not added, only the current is added. I is equal to I1 plus I2, and potential, see here, potential difference is the same. V is equal to V1, that is equal to V2, only I will be equal to I1 plus I2. Okay, current is equal, that will be, only the current will be added, I is equal to I1 plus I2, and potential difference will be the same. That is the difference between series and parallel. When it's connected in series, the potential difference will be added, and the current will be of the individual cell. When it is connected in parallel, the current will be added of the individual cell, and the potential difference will remain the same. Understood this? Okay. So like this, we were connecting the many solar cells in series and parallel, generating required current and potential difference are made. So series and parallel, they connected, and we'll get enough amount of current. For example, 36 solar cells are each of 100 centimeter square are connected in series in the solar panel. It will a potential difference of 18 volt and a current of 3 ampere. Many such panels are connected together to generate electricity in larger scale. So many 100 solar cells of 100 centimeter squares are connected. 36 are connected. Solar cells are connected, of each of 100 centimeter squares are connected. You will get 18 volt and 3 ampere of current. You can see here this figure. Okay. Of 36, this is a solar panel made up of 36 solar cell. They are connected in series as well as parallel. So when they are connected in series and parallel, you will get enough amount of current as well as potential differences also obtained. This is a solar panel which is made up of how many solar cells? 36 solar cells. Okay. Now we'll see what is a solar panel. So in a solar cell is the basic unit of solar electric plant. So one is called as a solar cell. Many solar cells come together to form a panel or a module. You can see, I'll show you the figure. So many solar cells join together to form a panel or a module, and many more solar panels connected in series forms the solar strings, and many solar strings are connected in parallel to form a solar array. So we can obtain as much electric power as needed by connecting in solar, like the series and parallel. You can see here, first is the solar cell. Okay, single it is called as what? This is the solar cell. When it is connected, many solar cells are connected like this in series. It is called as the module. And strings, modules, we can see many panels connected like this in a series. It is called as string. And many strings are connected in parallel to each other. They are called as the array. Okay, so when you connect like this, you will get enough amount of electric current as well as potential required potential difference is also obtained. Okay, the power available by the solar cells is DC. This already I told you, the electric power which is got from the solar cells is DC current. It is not AC. So in appliances which need DC power, that means LEDs. LED we need only DC current. So it can be used directly in LEDs. However, since the energy from solar cell is available only in the presence of sunlight, the energy has to be stored in batteries for use at later time. So it has to be stored because it directly, this energy cannot be used in any time because it is available only during the daytime in the presence of sunlight. So when we are getting this light, it has to be stored in the batteries. Okay, and this what we learned now, it is always in DC current. This in DC power, so it is used in LEDs directly. In others, it has to be converted into it has to be converted into AC current. Okay, most of the equipment in a domestic and as well as industries run with the AC power. So in such cases, what it has to be done, the DC solar power must be converted into AC using the device called inverter. They use the inverter to convert the DC current into AC current. Okay, because all the equipments of our house as well as industrial use, we use AC current, but when we get electricity from the sunlight directly, it is in the form of DC current. Only in LEDs you can use it as it is, but in other equipments it has to be converted into AC current with the help of an instrument called inverter. And this electricity, this power which is got is from the sunlight, it can be stored in the batteries. You can see in the diagram. See here, it is stored in the from the cell. It is got that is stored in the battery, and that is converted with the help of the inverter. It is converted into AC current. Okay, this is very simple. First, it is stored because it cannot be solar energy cannot be obtained throughout the day, only during the daylight when there is sun. So it has to be stored, and it is taken to the inverter, and this inverter converts the DC current into AC. Okay, understood now? Now let us go to the next part. Okay, many solar panels are connected together to generate whatever energy we need. I told you, like this, many solar panels are connected to get the energy we require. So the DC power generated from these panels is converted into AC. First is converted into AC. A transformer transforms the voltage and current levels of the generated power, and then it is fed into the electricity distribution work. That is you can see here how it is connected. It is going to the using the photovoltaic cell, how the power stations are made. You can see here many many, you can see panels are kept here like this. Arrays are there connected in series. It is from here an inverter is and transformer is kept that will convert the energy. So you can see arrays, they will energy from sunlight is going to the arrays, and then it is converted. It is inverter, and from transformer that will be connected to the household requirement. This is the schematic of solar photovoltaic station. Okay, this is the one type of energy we getting directly using the solar photovoltaic cell. The second type we are going to learn in this. Okay, this, what is this drawback in this? Electricity generated using any fuel combustion, so there is no air pollution. This is the advantage. But what is the disadvantage? Since the energy using solar cells can generate electricity, this you all know, only during daytime. Only during daytime this is the drawback, but there is no pollution because it is directly from the sunlight. There is no pollution. That is the advantage. Disadvantages, only in the daytime we can take this energy, obtain this energy. This is the drawback. Now let us see the second part. using solar thermal power plant. This is very simple, similar to your electricity from coal. We learnt about thermal plant as well as the nuclear energy from the nuclear fission, like the nuclear energy. Same way, in this also thermal, it is converted into thermal. Solar energy is converted into thermal energy. Okay, this thermal energy can also be generated from solar radiation and also can be used for electricity production. Different stages we can see how we are using the solar thermal power plant. We saw in the normal thermal power plant, we use coal. That coal is converted into steam, and the thermal energies, that steam thermal energy is produced, that is rotating the turbine, and then you will get electricity. Even since nuclear fission we saw, due to the fission reaction, now you will get a high temperature of steam that will rotate. The same way here also we are seeing the schematic. You can see here, see concentrators for collecting sunlight, then absorber for absorbing the converted sunlight, concentrated sunlight, and it's converted into steam turbine, then electric generator, and then the electricity. Same way, only the concentrators are kept to collecting the sunlight. We keep the concentrators, they have to, you can see in many of the terraces they keep this equipment where the sunlight is absorbed with the help of the concentrators. They collect the sunlight, and absorber for absorbing the concentrator, there are absorbers. Okay, first it is collected, then it is absorbed, that absorber is kept to absorb the sunlight, then it is it is converted into steam, that will rotate the steam turbine, that is connected into electric generator, going to the electric generator, and then that will be converted into electric energy. You can see the schematic diagram also in this. See here, first we can see concentrators. Okay, I'll show you the figure also. Many reflectors and that reflect and concentrate solar radiations and on absorbers. The solar energy is converted into heat energy. Using this heat energy, steam is generated to drive the turbine and generator. Same way as we learnt in, you can see in this diagram how the reflectors are used. They will here you can see their reflectors. They will collect the sunlight and they will absorb it, and it is taken in this panel. It is moving the water. See here, the water is heated over here. It is taken through this and the panel over here, and that will be heated. It is converted into heat energy, and then steam that rotates the turbine, and it goes same way. The water is cooled over here, and it is going back to the similar process. Only the source is different. Here we having the solar radiations that will convert into the water into steam energy. Okay, this is the lesson is over, children. In the next video I will revise the full lesson, and then we will move on to the next lesson. So today we learned about solar energy, one directly from the photovoltaic cell, and the next one from, and the same way how solar energy is converted into thermal energy, and then that is rotating the steam turbine, then you will get the energy. So this two processes we learned today, and the lesson is over. I will revise the full lesson in the next video, and then we will continue. We will go to the next lesson. Hope you all understood everything, children. Thermal power plant, then we learnt about nuclear fission, then we learnt about fuel. Okay, we learnt about CNG, natural gas we learnt. Then we learnt about hydroelectric power station. We learnt about wind energy. Now we are learning about solar energy. These last three what we learnt were the green energy, because it does not cause any pollution. Okay, now we will finish this lesson. I will revise this lesson in the next video, and then we will go to the next lesson. Hope you all understood, children. Thank you. Saira.